Hello everyone. In this video, we'll be solving problem 498, diagonal traverse. The problem statement is, we are given an m by n matrix. We need to return all of the elements in the matrix in the diagonal order. We start with the first element in the matrix, that is 1, and move upwards. And once we hit the ceiling, we then switch the directions and start going downwards. So after 1, the next element is 2. And if we continue going downwards in the diagonal direction, the next element is 4. And as 4 is the last element in that diagonal, we'll pivot or change the direction starting with 7 as the next element and move upwards. And during the traversal, all of these values should be recorded in an array and returned as the output. The problem statement is very easy to understand. Let's switch to whiteboard and discuss how we can solve this problem. Let's start by identifying some of the rules that will help us come up with a solution. As there are two different directions, upwards and downwards, we should have different set of rules for each of them. Starting with the upwards direction, when we want to move to the next element, we will have to decrement the row pointer and increment the column pointer. And for downwards, we are basically incrementing the row value and decrementing the column. I hope this part was clear. The next thing we need to be careful about is the validations to make sure that the pointers do not go out of bounds. If our pointer is pointing at element 1 and we decrement the row value, it will become -1, which is out of bounds. Ideally, the pointer should be shifted to the next element in that row, that is 2, along with changing the direction. The same logic applies when we are going in the downwards direction and we reach the last element. Let's say our pointer is pointing at 7. There are no elements after that, so we need to now change the direction and increment the column value. So this logic of incrementing the column pointer applies to both the directions. Here's the mathematical representation of the logic that we just discussed. If the row pointer is greater than or equal to r max or less than 0, we should increment the column pointer by 1. There's one more case that we need to take into account. Let's say my pointer is pointing at 3 and we are going upwards. After that, there is no element, so we should ideally increment the value of the column pointer by 1. But there is no more column after 3 as it is the last column. So we'll be again getting out of bounds error if we use that logic as is. So instead we need to increment the row pointer so that we can switch to 6 and then change the direction to go downwards. To support this criteria, we also need to take into account the column value. The logic is very similar, where if the column value is greater than or equal to column max or less than 0, then we should increment the row value by 1. This logic applies to both upwards and downwards direction. If we can implement these three rules, we can easily solve the problem. With this solution, this time complexity is going to be O of m into n, where m and n are the number of rows and columns in the given matrix. This is because we are traversing through the input matrix only once, while the space complexity is O of 1, as we are not creating any additional collection besides the one where we are recording the values that needs to be returned as the output. If we include that into the calculation, then the space complexity will be O of m into n. I hope you are able to understand the explanation. Let me show you how we can implement this using C#. In this C# implementation, I have added a validation to make sure that the matrix is not null and it contains at least one row. After that, I have initialized few variables that will be used as pointers for row and column and an integer array result. After that, I am starting a while loop until the index pointer is less than the size of the matrix. Inside the while loop, I am saving the value in this matrix that is pointed by the row and column into the results array. If the upward flag is set to true, then I am checking if the column is equals to column max, that is the maximum number of columns. If yes, then we need to pivot and change the direction while incrementing the row pointer. Else we need to check if row is equals to 0, as we cannot go any further after that. So in that case, I am incrementing the column pointer and changing the direction by setting upwards to false. If either of the conditions are not met, it means there are few more elements we need to traverse, and in that case, I am decrementing the row pointer and incrementing the column pointer. In the downwards direction, we will enter the else block where we'll first check if row is equal to the maximum number of row. If yes, then I'm incrementing the column pointer and changing the upwards direction to true. If not, then I'm checking if column is equal to 0, that is the minimum column. If yes, that condition is suffice, then I'm incrementing the row pointer and setting the upwards flag to true. If either of the conditions are not met, it means there are few more elements to be traversed. In that case, I'm incrementing the row pointer and decrementing the column pointer. After the while loop is complete, I'm returning the result array as the output. This code, when submitted on LeetCode, beats nearly 95% of the submissions in terms of runtime and 88% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you on the next one. Thank you.